Welcome to Lesson 1-7, Day 2, Adding and Subtracting Integers. Today we're going to be focused on subtracting integers. So one of the first things that we want to talk about are our objectives. So today we're going to be able to subtract integers, identify a number's additive inverse, and solve problems involving subtracting integers. In order to do this, one thing that I do want to touch base on first is the three rules that we discussed in last lesson. So 1, a positive plus a positive equals a positive. 2, a negative plus a negative equals a negative. And then 3, remember the positive plus a negative means you're actually going to subtract, and your answer takes the sign of the number with the biggest absolute value. Okay, so you want to keep these three rules in mind, and it'll definitely help you out today when we talk about subtracting integers. The other thing that will help you is in your vocabulary you have the additive inverse. The additive inverse are two numbers whose sum is 0. Two numbers whose sum is 0. So if I take a positive 10 and I add a negative 10, we know that our rule is, since it's a positive plus a negative, I'm actually going to subtract. So I do 10 minus 10 and I get 0. So negative 10 is 10's additive inverse. Okay, so if I had negative 9, negative 9's additive inverse would be positive 9, because when you add those two things together, they give you 0. Alright, so remember that the minus sign means to move left. So in this case, when I have a negative 2, so if this is 0, and I start at negative 2, the minus sign means to move left. Okay, but now here I have minus a negative 9. So they change each other. So this says move left, and then this says, nope, do the opposite of that. So you're actually going to move right. So in this case, moving left negative 9 spaces, it's not going to work very well with the number lines. So what I like to do, instead of using the subtraction and then the negative, I like to change it because we have rules for addition. So I like to change it so that way we can use the additive inverse and make this into an addition problem. So what this means is, instead of subtracting the negative 9, I'm going to add its additive inverse. So I'm going to keep my starting point, which is negative 2, but then I'm going to add negative 9's additive inverse, which is positive 9. Okay, so basically what you're doing is, if it's a subtraction problem, you change it to add the opposite. So now this becomes negative 2 plus 9, and now we can use our addition rules. Okay, and remember again, our addition rules are positive and a positive always gives us a positive. Positive and a negative will always give us, or I'm sorry, a negative and a negative will always give us a negative. And a positive and a negative, the solution will take the sign of the number with the greater absolute value, and we actually subtract. Okay, so then to solve this, okay, so these two things are equivalent. Negative 2 minus a negative 9 is the same thing as negative 2 plus 9, because this sign means to do the opposite. So this tells us to move left, and now this tells us to do the opposite. Or you can make it easy on yourself, which I think this will be the best for everybody, is if we say, nope, we're going to add the opposite, or add the additive inverse. So in this case, I know my answer is going to be positive, because 9 has the greater absolute value. And then because it's a negative and a positive, that means I'm actually going to use subtraction. So I'm going to subtract 9 minus 2, which gives me 7. And because I know my answer was positive, because of our rules, my answer here is a positive 7. Now if I go back to using the number line, Okay, so because it says to move left, but then it says to do the opposite of moving left, and I mean to move right, I would go 1, 2, 3, 4, 5, 6, 7, 8, 9, and I would end up at positive 7. But instead of making our life that complicated, let's just change everything to add the opposite, or to add the additive inverse. So I'll do the first one with you. So I know that you have this in your notes. Okay, I will do the first one with you, and then you have these next two to do on your own. So we keep the -5. We never change our starting number. But I don't want to subtract. I actually want to add. And the opposite of -7, or the additive inverse of -7, is positive 7. So I want you to go ahead and take a minute and pause and rewrite these as adding the opposites or adding with the additive inverse. When you come back, we'll go over your answers. All right, so for 3 minus 7, you should have gotten 3 plus a -7. Okay, so subtraction turns into addition, positive 7 turns into -7. And for 4 minus a -8, subtraction turns into addition. -8's additive inverse is 8, so it turns into a nice little addition problem for us. Okay, so once we change these, this is where the struggle comes in. Once we change these, now that it's an addition problem, now our rules apply. You never want to change addition to subtraction because we don't have subtraction rules that make adding integers easy. Okay, so we're going to do the first couple together, and then you have these to practice on your own. All right, so I have -4 minus 8. So instead of, I have to keep the -4, but instead of subtraction, I want to change it to addition, and I have to change this positive 8 to a -8. Now I use my rules. Negative and a negative means my answer has to be negative, and that I can just go ahead and add. So 8 and 4 will give me 12, so my answer is a -12. 14 minus 17, the 14 stays the same. Subtraction changes to addition. Positive 17 turns into a -17. Okay, so because -17 has a bigger absolute value, my answer is going to be negative. But because it's a positive plus a negative, I'm actually going to subtract and do 17 minus 14 gives me 3. So my answer is a -3. Now, when you have problems that involve multiple steps, you have to only go one piece at a time. So in this case, I keep the 14. The subtraction changes to addition. The -10 changes to a positive 10. And then I just keep the -4. 14 plus 10 is 24. -4. Now because both of these are positive, I don't have to do any changing. And I can just do 24 minus 4 is 20. But now, even if I did change it, so let's say I changed the 24 minus 4 to 24 plus a -4, I know that my answer would have to be positive because 24 has a greater absolute value than 4. And I know that because it's positive and negative, I would actually end up subtracting, which is exactly what I did here. And I would get 20, and my answer would still be that positive 20. So this, you'll see, is actually the exact same as this. Okay, so I'd like you to do now is you have these 3 problems. I'd like you to try them on your own, and when you come back, we'll go over your answers. All right, so for -6 minus 7, you should have gotten -6 plus a -7. I like to put my negatives in parentheses. It just makes it easier for me. A negative and a negative gives you a negative when we're adding. 6 plus 7, because they're both negatives, I can just add, gives me 13. So my answer here is a negative 13. Okay, this would turn to 7 plus a negative 7. Now here's the thing, because 7 and 7 are equal, I know I do subtract, and my answer is going to be 0. So whenever you see that your absolute values are the same, you know your answer is going to be 0. Because this negative 7 is the additive inverse of a positive 7. And here we have 4 plus a positive 7, because we add the additive inverse, so add the opposite. 4 plus 7 is 11, and because they're both positive, we don't have to do any extra or different work. Alright, so then the last thing I would like you to do is I'd like you to solve these 3 problems on your own. And this is what I want you to post to Edmodo, these 3 questions. So you are posting the answers to 7, 8, and 9. As always, if you have any questions, be sure to post them to Edmodo so we can go over them in class tomorrow.